Have you ever wanted to take your projects on the go instead of using a bunch of big bulky cords? Well, in this video, I'm going to show you exactly how to do it without your project ending up like this. Before you build anything, you're going to have to answer one question. What battery should you use? Most of the time, you have alkaline, lithium-ion, or lithium polymer. If you're building something low power, like a temperature sensor, a small project, or something that's off most of the time, standard alkaline batteries are great. But the moment you start adding Wi-Fi, motors, or anything that draws more current, they become a crappy option and don't output much current. And that's where lithium-based batteries come in. Lithium-ion and lithium polymer batteries are compact, rechargeable, and can deliver a lot more current when your project needs it. But what's the difference between the two? Both are 3.7 volt cells, and both charge up to 4.2 volts. Electrically, they behave almost the same. The difference is mostly in form factor and design. Lithium polymer batteries are more compact and can easily output more current, but they also can be damaged more easily. Lithium-ion batteries are bigger but usually have better capacity and are more protected. And actually, in my next video, I'm going to use this exact type of lithium battery to power a custom ESP Game Boy build. So that could be an example of something you could do with battery power. For this demo though, I'm going to use the lithium polymer battery just because it's lightweight and can handle the needs of a microcontroller. Now, all you're going to need is a breadboard, an ESP32. This one is a V-Room model 32E, and then your battery. Now, you can't just go plug your battery straight into something like an ESP32. The reason being is these batteries drain to around 3 volts, which is below the minimum voltage needed for the 3.3 volts that the ESP32 takes. That can cause things like random resets and unstable behavior. To fix this, you're going to need something like a boost converter to bring the voltage up to 5 volts and then send it to the 5 volt pin on the ESP32 so it has more consistent power. Now, what if instead of having a lower voltage, like 3 volts or 3.7, you had something like 9 volts? Then we would use a buck converter to step the voltage down instead. But converters don't create energy, they convert voltage into current. When you boost voltage up, you output less current. When you step voltage down, you gain more current on the output side. Buck converters are generally more efficient when your battery voltage is already higher than your target voltage. Boost converters are ideal when you're starting below your target voltage. Now that we figured out how to get the correct voltage, you're probably wondering, how do you charge up the battery? That's where a circuit like the TP4056 module comes in. I know it's a mouthful, but they work great. This allows you to safely charge the cell to its 4.2 volt maximum without overcharging it and exploding your battery. This specific one, which I got off Temu, also has a short circuit protection, which definitely comes in handy when you're starting off and you don't exactly know what you're doing. Now that we have everything we need, let's put it together and hook it up to an LED. Take your charging module and your battery, negative to the B minus, and then your positive. If I can get that on. Slap a little bit of solder on there. I'll take some spare wire I got laying around. Attach it here first. Trim up our ends. Your V in positive, and then your V in negative. Attach it up. Oh, my battery's not charged. Okay, we're back. So after some trial and error, I just found out that this battery is just dead and doesn't work. So I switched it out with just another LiPo battery from an old vape. But this one was from a drone, so I'm not exactly sure what happened to it, but it's garbage. Now, as you can see, I got everything set up. Battery going to the charger, charger going to the boost converter. Currently, it is outputting 28.8 volts. It's got a little potentiometer here. We're just gonna spin it until our voltage drops to our 5. There we go, exactly 5 volts. And then I'm just gonna attach some more wire so we can run it to our breadboard. And there we go. I'll take our positive and put it in the breadboard, and then our negative. Just with some jumper wires, I can run our negative to the ESP's ground, this pin right here, and our 5 volt is this pin right here. And there you go. We're powering our ESP. Now, just as a test to see if it outputs power, we can take our 3.3 and our ground. See on our LED, we got long positive, short negative. You can take a resistor, and then final step, take our ground, And there you go. As you can see, we're powering the ESP with this battery setup. Now that we have everything powered on and everything set up, all you need to remember is that you need a safe charging system with some kind of protection, and then a voltage regulator of any kind. If this tutorial helped you whatsoever, please hit subscribe and let me know which project I should do next. Thank you.